Hello friends and my dear students, hope you are safe at your places. So in the last session we have discussed about many things related to the mechanical vibrations. If you go through the previous videos which I have uploaded on Engineering College Banswara YouTube channel for third year 6th semester BTECH Mechanical Engineering students of Rajasthan Technical University. So I have covered the introduction of the sound in which we have discussed about the human response to the sound as well as relationship between the sound power. Then I have discussed also the introduction of noise, in which auditory and non-auditory effect of the noise and what are the major sources and what are basically industrial noise control strategies. After that we have discussed about the concept of degree of freedom, harmonic motion. Okay. Then in the undamped single degree vibration system we have discussed about one dimensional, longitudinal, transverse, torsional we will discuss soon. Without damping, okay, and Newton's second law we have discussed as well as we have discussed about D'Alembert's principle and the principle of conservation of energy, which we have discussed in the last, which is called as energy method. So today in this video we will try to cover the compound pendulum and center of percussion, and from the next session onwards we will jump into the damped vibration, okay, which will be damped vibration will be covered from this part to this one. Okay, so in this way we'll try to cover your unit 3. Okay, so stay tuned with Engineering College Banswara YouTube channel for more such updates. Okay, let's get it started with the compound pendulum. So basically compound pendulum is a kind of experiment which you have gone through in your 12th physics as well. So here what you have to do in the simple pendulum, which consists of a small body called as bob, okay, and attached to an end of the spring, if you have seen it, okay, and it is which is greatly compared with the dimension of the bob, okay, the mass of which is negligible in comparison with the bob, means whatever the string, that mass is not considered. Okay, under these conditions the mass of the bob may be regarded as concentrated at its center of gravity, means if bob is a kind of ball, then the center of gravity will be the center of that ball. Okay, so the length of the pendulum is the distance of this point from the axis of suspension, while when dimension of the suspended body are not negligible, means that string, that suspended body is not negligible in comparison with the distance from the axis of suspension that to the center of gravity, that pendulum is called as compound pendulum or physical pendulum, means that string dimension or string mass will also be considered here in compound pendulum, okay, while in simple it is not considered. So I'm just covering few highlights of this one only. As you can see in the picture, this is the compound pendulum, you can imagine, and this is the center of gravity for this particular suspended body, and this is the O. From this it has been deflected to angle theta. Then your restoring torque, means which will just restore it to the original position, that is called as your tau, or you can say torque. Okay, while your for the smaller angular I will say smaller amplitudes, your theta will be equals to 0, while your for the other sections it may be considered as I d2 dt d2 theta by dt2, means this double integration of this particular term, which will give you the value of the torque here, which will be equals to mgl theta. So keep this formula in your mind so that you should not again remember this particular term. So with the help of that you can got to know that this t will be, or the time period of oscillation will be 2 pi under root I by mgl. But here I is not simple mass moment of inertia, here it is I is equals to ig plus ml square, where ig is moment of inertia of the body about an axis parallel to the axis of oscillation. Okay, so that's why this I become as mk square plus ml square here, and this formula for compound pendulum, time period for the compound pendulum will look like this. And if you will compare this with simple pendulum, then it will give you the comparison of the length L. L is equals to small l plus k square by small l. Okay, so this is called as equivalent simple pendulum, means if this length will be replaced, then it will become a equivalent simple pendulum. Okay, in this way you can also derive that what are the relationship between G and K, and you can also develop the graph, means what are the procedure you can go through it. I will just highlight this for your reference. Okay, you can go through it and try to perform this experiment and get the data recorded in your book. Okay, so that whenever it is necessary you can also plot the T versus D, means time period versus diameter of the bob graph. Okay, go through it. Okay, and just calculate the value of G and K on the basis of T and D graph. And after that, these are the precautions and discussion which you have to measure at the end of your experiment. So just try to perform this experiment in your lab whenever it is feasible. We will try to come with the next session of this mechanical vibration in upcoming days. Thank you so much for your patience hearing, and stay tuned with Engineering College Banswara YouTube channel. Thank you so much. And meanwhile, if you have any kind of doubt, you can also ask in our comment box of this. Otherwise, whenever it is feasible, you can also contact to the faculty. Thank you so much.